I want to come with you.
Our goal with robots is to have robots helping people, and not only the geek. I want to have robots helping everyone. But in order to do that, we need to have the robot accepted by people. I'm Bruno Maisonnier, head of Aldebaran Robotics, founder and CEO of the company.
Give me something, please. Thank you.
We think that the robotic market is going to be huge in the future. And this comes from the simple fact that the world population is aging very fast. And we need robots to do whatever they need at home.
What do you want me to do?
When people are depending on someone else and need to have someone else helping them, they are in a secondary position. But when they have a robot doing that, they are in the first position. They are leading. Notre Dame University, United States, they are really working with robots helping autistic kids. So we discovered that robots are objects they can interact with, they are comfortable with interacting with robots, they like it.
The first impression that you get when you see the robots is the outside shapes. If the shape, if the form is too aggressive, you won't interact with that robot.
There are many people ready to develop softwares, but we are just lacking robots. We are just missing robots. So that's why Aldebaran began with a platform for providing all those who want to explore this new world, who want to be part of this revolution, to be able to do it.
I've been working for Aldebaran Robotics for 5 years as a mechanical engineer. I especially work on designing gears and integrating motors into the platforms we develop at Aldebaran. Well, like Ludovic, I am also a mechanical engineer. I mainly work on the shells, but also on internal parts and the structure. For each project, the process is similar. We start with sketches, essentially 2D images, that we then translate into digital data and 3D volumes using SolidWorks surfacing tools.
This gives us the ability to rotate the pieces and robots in the space and to improve the design when it's not as pure as we want it to be.
So we start with the exterior design of the hand as we have here. It is smaller than a human hand. It's the size of a small child's hand. And inside there are over 100 parts just for one hand. In addition to all mechanical constraints, we have 2 degrees of freedom that we have implemented in this hand, and SolidWorks allows us to look at all the possibilities and optimize the mechanical design inside the hand. Even more complex is the robot's head, which combines mechanical, electronic, and optical components, like cameras, for example. One might say that all Now's intelligence is gathered in its head. There are also LEDs, microphones, and speakers. We use SolidWorks simulation, which allows us to generate digital models and know if the part will resist to shocks or not, based on stresses we apply to it. And once we have proceeded with validation in SolidWorks, we can move on to production.
We use SolidWorks in order to project the product into the future, and we can really optimize, really improve the parts before it exists, before it is manufactured. You have to know that into that robot there are more than 1,200 plastic parts. On my team, there are 45 people working on the design, and I need to orchestrate the daily work and make sure that when we create new parts, the version is correct. So for that we use EPDM, and it helps us to focus on innovation while EPDM is taking care of the structure of the project.
I hate the techno stress. I don't want to have devices that are asking me to invest intellectually to understand how they're working. So I don't want my robots to create techno stress to people. When you want to change the world, to improve things, you have to go beyond what you are able to do. You have to decide to go for something you don't know how to do. It's a new territory to conquest.
Shall we try something new today?